we take roots, we found out that we can divide the exponent by the index. However, we can't always divide the exponent by the index for the entire product. Instead, we might just have to divide the exponent by what we can. Remember, square roots is always a 2. And pull 1a out, and leaving the b behind inside the radical. An a outside the radical, and a b left over inside the radical. This same idea works for higher roots. As we divide n by n, we get 1, or a to the first, coming out of the radical. But the b is left inside the radical with the index. Also, sometimes when we divide, the number doesn't divide into the exponent evenly. If there is a remainder, the remainder will remain in the radical. This means the number 2 might come out a few times and also be left inside the radical a few times. Let's take a look at some examples where we have to find a radical of 72, for example. We again will find the prime factorization of 72, divisible by 2 36 times, 2 18 times, 2 9 times, 3 3 times, and 3 once. 72 is 2 to the third power times 3 to the second power. Square root has an index of 2, and so to decide how many 2's are going to come out of the radical, we will divide the exponent by the index. 2 goes into 3 once. That means 1 2 comes out. However, when we do 2 into 3 once, we're left with a remainder of 1. This means one of these 2's, or 2 to the first power, is going to remain inside the radical. On the 3 squared, we can divide that exponent 2 by the index 2, and we find out that the number of 3's coming out is 1 perfectly. Coming out, we have 2 times 3, or 6, and left inside the radical is 2. 6 times the square root of 2 is the simplified form of the square root of 72. When we can't take the square root perfectly, we'll take the square root of what we can, leaving the other stuff behind in the radical. Let's take a look at another example. Here we want the third root of 750. Finding the prime factorization of 750, divisible by 2, 375 times, divisible by 3, 125 times, divisible by 5, 25 times, divisible by 5, 5 times, and 5 once. We get underneath the cube root 2 times 3 times 5 to the third power. Notice there is no exponent to divide with the 2 and 3 bases. The only exponent we have is on the 5 cubed. We divide the cubed by the index of 3 to find out how many 5's come out. 3 divided by 3 tells us that one of them is going to come out. We have a 5 on the outside of the cube root. Left inside the cube root, we see 2 times 3. 2 times 3 is 6, and so our answer is 5 times the cube root of 6.